Cauchy's integral formula. The statement goes like this: if f of z is analytic inside and on a closed curve C of a simply connected region and if z0 is any point within C, then f of z0, value of f of z at the point z0 is given by 1 upon 2 pi I integral over C f of z upon z minus z0 dz. Okay, so that is Cauchy's integral formula. That means here the theorem, the formula states that, or from here again you can write, therefore we will be asked to solve this one, integral of f of z. So from here, integral f of z dz or over C, f of z dz upon z minus z0. This will be our question. Evaluate this. Will be, this is equal to, from here means this part, this will be 2 pi I into f of z0, means just multiplying this to this side. Okay, this will be, this left side part will be your question. Evaluate f of z under these conditions and all. So it will be 2 pi I into f of z0. So now this states that if f of z is analytic in and on a closed curve C of a simply connected region, that means suppose you have a region, a simply connected region R, a big region R, then C is another closed curve inside this curve. Okay, C is another closed curve inside this region. Then, so if I'll just remove this one. Okay, I'll just tell about this one only. So C is a closed curve inside simply connected region, or of a simply connected region R. Then suppose a function f of z is given, that f of z is analytic in and on a closed curve C. Okay, and suppose z0, there is a point z0 inside this C where the function is not analytic. Okay, suppose I am defining f of z is equal to 1 upon z minus 1 into z plus 1. I am defining a function like this. In the interval, say inside the interval or within the circle, say C is a closed circle, say mod of z is equal to 2. So we are defining f of z equal to 1 upon z minus 1 into z plus 1 over the circle mod z equal to 2. So you know, so mod of z equal to 2 means circle with center 0 0 and radius is 2. Okay, so from here you will get z equal to 1 and z equal to minus 1 are 2 points where the function is not analytic. Z equal to 1, when you put z equal to 1, this function does not exist, and when you put z equal to minus 1, denominator becomes 0, means the function is not analytic there. So now z equal to 1, if you look at that one, we consider one function, so it will be easy because the other is different case. So now z equal to 1 is the point at which this function is not analytic. So if you look at the region is what? It is 0 0 and radius is 2. Okay, here radius is 2. So the point z equal to 1 is a point inside the circle, inside this C. So C is this one. So z equal to 1 is a point inside this circle, except at that point, except at z equal to 1, that function, this given function is analytic everywhere over this region. Except at z equal to 1, everywhere the function is analytic in this given region. Okay, given closed curve. So that z equal to 1 lies inside the circle. If it is like that, means a point at which the function is not analytic, if it lies inside the curve, then we apply what? Cauchy's integral formula. So that is what is written. Z0 is any point within C where the function is not analytic. In that case, f of z0 is given by 1 by 2 pi I integral over C f of z upon z minus z0 dz, or from there you will get, means this we can evaluate by 2 pi I into value of that function, means value of the given question, value of that function at the point z equal to z0. Okay,